Last time we met, we talked about compound interest, and the most basic form of compound interest would be like annual interest, where the compound is paid out once every time period. And that equation, we have y equals b times m to the x. So if I had $30 and I had 5% interest gaining, and I compounded once a year, I would do 30 times 1.05 to the x, and then I just plug in how many years I had. But what if I compound twice? How do you compute that by hand? You would do 30 times half of the yearly interest, which would be 2.5%. So you could do 30 times 1.025, 1.025, meaning you pay half of the interest every compound, and that's going to change the number of compounds. So if I'm plugging 4 in here, what do I need to plug in there? 8, because I doubled the number of compounds, the number of payments. Okay, and we came up with the equation y equals the principal times 1 plus the rate divided by the number of compounds, which is what we did here. Right? We took that 0.05, we divided it by 2 because there were 2 compounds per year, and then you raise that to the number of compounds times time. And that formula looks really confusing, but if you think about it in terms of you're just paying portions of the interest more often, then it makes quite a bit of sense. So on this assignment today, suppose you have a bank account that collects compound interest. The bank has a plan where you can pick how many times per year the interest is paid. Sounds like a good idea, right? What are you going to pick? As often as possible. The more compounds, the more you make. Okay. The catch is that the bank charges an increasing fee according to the number of times the interest is paid per year. So you plan to invest $2,000 at 8% for 5 years. Using the fee chart below, determine the number of compounds per year that will earn you the most interest over the 5-year period. So obviously, if the bank just says, pick however many times you want to compound it, you're going to pick the largest number. But in this case, the more compounds, the more that account is going to cost you per year, and that's going to offset some of the interest. So our goal here is to figure out which one is the best deal. So in the chart to the right, calculate the number of compounds associated with each interest option. Annually would be 1, semi-annually 2, and then 4, 6, 12, 52, and I'm going to want to move this out of the way. I'm going to need a calculator in a second. Daily is 365, and hourly is 87 what? And how did you get 8760? 365 times 24. And then how do we get minutely? And multiply 8760 times 60. Wow, 525600. Okay, how about every second? Times that by 60. And so 3, oh my goodness. I am so tired of this conking out on me. Okay, yes, I need to save that. Okay, I think I fixed it. So 3153600, and what about 3 times a second? How are we going to find that? Just triple this number. So 9460800. Okay, Without calculating the interest, which option do you think will make the most money after you subtract off the fee? So basically you're just going to check one of these, just guess. Which one is going to be the best idea? Now, the bottom one, the 3 times a second version, is definitely going to pay you the most interest. But the question is that interest enough that I can subtract off $14 and still have the highest amount? Okay, so just guess. Okay, and then we're going to use the compound interest formula to calculate how much money will be in the account after 5 years. So the way this works is, for annually, we're just going to take $2,000 and we'll do the regular exponential formula. 2,000 times 1.08, and how many years is it? 5? Raised to the 5th. And this one ends up with 2,938 and 66 cents. Okay, and that particular account doesn't cost anything. So at the end of 5 years, we still have 2,938.66. Okay, now for semi-annually, we're compounding twice. We need to use the compound interest formula. So this time it's 2,000. And we'll times that by 1 plus, the interest rate is 0.08, but we need to divide that by 2 because we're compounding twice. And then because we're compounding twice, we need to raise it to the 2 times 5. Semi-annual compound for 5 years will result in 10 compounds. And we get 29.60 and 49 cents. Okay, but that account costs $5 a year, so I need to subtract off 5, and I get 2,955.49. Is the semi-annual program better than the annual program? Yes. Even with a $5 fee, we're still making a little bit more money. Okay, so I'm going to give you some time to go ahead and finish the whole front of that, and then we're going to move on to continuous interest. So I'm going to pause the video and you guys finish that up. So here are calculations that were provided by an unknown member of the class, but her initials are Bell Bowers. So, which option will make you the most money after the fee is assessed? Looks like this one. That one won by 12.22 cents. Okay, now that's really not the purpose of this, but what do you notice about the interest you make as n gets larger? So this is the column that really is going to teach us what we need to know. And these numbers are getting really big. They start off 1, and then 2, and then 4, and then 6. We're not growing a lot. 12, 52, and then down here we're up in the billions or trillions or something, right? So when this number on the left gets really, really big, what happens to the interest? What? It starts slowing down. So the difference between these two is about $12. And then the difference between these two is only $11. And then $4. And then $4 and $3 and less than $1. And then we get down to the bottom and we can't even tell the difference in cents between every second and 3 times a second. So every second was 31 million, and 3 times a second was almost 95 million compounds. But do you see how the interest is slowing down? So in my original question, I asked you, how many compounds do you want? And you would say the biggest number possible. So what is the biggest number possible? Infinity. We want to compound an infinite number of times. And you might think, if you compound an infinite number of times, you're going to make an infinite number of money. Doesn't that seem reasonable? But looking at this, Apparently, there is no difference between every second and 3 times a second. And does anybody have those numbers on their calculator? How far out do you have to go before you see a difference? Is it way past a penny? It's quite a ways out there. How many decimal places before you see a difference? 5? So yeah, you've got to go out to a thousandth of a penny before you notice a difference between every second and 3 times a second. So hopefully you realize that there is an upper limit to the amount of interest you can earn using the compound interest formula. Okay? Is there any way after 5 years that I could have $3,000 if I kept making these numbers bigger and bigger and bigger? So if I have $2,000 and I'm compounding 8% as many times as I want, is there any number I can plug in for n that will make the value at the end of 5 years equal to $3,000? And it doesn't look like it, right? If I put an even bigger number in, I'm probably still going to get 83.66 cents. Does that make sense? So the interest has an upper limit. Okay. Well, what happens if you plug in infinity into the equation? So I have the equation. Gosh. Oh my heavens. I'm going to be calling Canada, telling Smartboard their stuff isn't working. Okay. Oh, we might be okay. So I have y equals p times 1 plus the rate over n, raise it to the nt. So I want to plug in infinity right here and right here. And I get y equals, we did 2,000 times 1 plus 0.08 divided by infinity raised to the infinity times t. Well, what is 0.08 divided by infinity? If you take 0.08 and you cut it into an infinite number of pieces, how wide is each piece? Tiny. In fact, it's so tiny, it's actually 0. Because we can't, right? If it has a width, you didn't cut it enough. Does everybody understand that? So any number divided by infinity, except infinity, that's infinity over infinity is a problem. That's a calculus thing that we're not going to do today. But any number divided by infinity is 0, essentially, because if you take that ruler and you start chopping it, and you end up with a piece that has a width, then you didn't cut it into enough pieces, so you have to keep cutting. So eventually it's 0, so that's a problem. This turns into 0. And then what is infinity times time? It's infinity, and we end up with 2,000 times 1 to the infinity. But what is 1 to the infinity? It's just 1. 1 times 1 times 1 times 1 times 1. So it all just falls apart. Okay? But there is a way through calculus that you can figure out what this equation truly equals. And that's where the number e comes in. Okay? So there are actually 3 compound interest formulas. 2 of them you already know. So the first one is y equals b times m to the x. That's just the regular yearly compound. Okay? And then this one handles any compound from 1 up close to infinity. Okay? But if you calculate the interest every instant of every second, then we use what is called the continuous formula. Okay, and that is y equals p e to the RT, the PERT equation. Now, e is an exponential number, and if you type e into your calculator and push enter, let me find it. So lowercase e, it's the divide button. So e is about 2.718. And it's a number like pi. It's irrational. It goes on forever. It never repeats, and it has a ton of applications in mathematics, especially when you're talking about compounding continuously. Okay, now, is compounding continuously going to be very much bigger than compounding, say, 10 million times a year? And the answer is no, not much. But if you were allowed to plug infinity into the formula, you would end up with PERT. And it's a little bit weird because this is no longer a percentage. You know, like 1.07 would be a 7% increase. The rate has moved up into the exponent, and n has disappeared entirely. So it's a little bit strange as far as the formula goes. And you might ask, when do we use PERT? And the truth is, PERT is for every exponential situation except for money. Anything in the real world compounds continuously. The only things in the world that don't compound continuously are our bank accounts that we have created. Everything else, bacteria growth, erosion of a rock, anything that grows and or decays by a percentage will use PERT. So for any real world situation, we're going to use PE to the RT. If it's a bank account where there is a specific number of compounds, then we use the middle formula. And the top formula really is quite useless. That doesn't really ever happen anywhere. Okay. So, oh, I don't know if you wrote that down. Whatever. Write the formula. I wasn't paying attention to the worksheet. So, how does PERT work? Yes. Oh, sorry. P equals e to, nope. Y equals P e to the RT. Okay. So, number one, if $18 is compounded continuously at 7%, how much money will there be after 9 years? So our principal is 18. We multiply that by e raised to the, our interest rate is 0.07. And then we're going to do that for 9 years. And if you look at the ln button on your calculator, there's an e to the x. We almost never use e in mathematics without an exponent above it. Sometimes we do, but almost every time you see e, there will be an exponent on it. So I type in 18, and I raise e to the 0.07 times 9. Okay, and I end up with $33.80. Now, that is the most that you can ever earn in 9 years using 7% interest. But continuous interest is really not that much more than daily interest. So let's calculate the daily interest. 18 times 1 plus 0.07 divided by 365, and raise that to the 365 times 9. Okay? And you'll notice the difference in this case is less than a penny. And if you rounded it, it would be 1 cent. So banks today pay you daily interest. But the trick is they don't put it in your account for 3 months, which means the interest doesn't earn interest. So it's a really weird system. You get daily interest, but it's only compounded 4 times a year, which is kind of weird, right? If they put it in your account every day, that would help. So daily interest and continuous interest are actually pretty close. And let's do these same calculations for, say, 30 years. So if I do a 30 here, I end up with 146.96. And then if I go up to the PERT equation, and then I change the 9 to a 30, then I end up with 3 more cents. So it's really not that big of a difference. The PERT equation and using 365 is not much of a difference. Okay, are all of these going up? Yes, they are. Okay, any questions? Do you kind of have the hang of that? Okay, go ahead and finish that.